a student threw a ball horizontally at 2 meters per second, as shown in your diagram, horizontally, okay? And it is an altitude or height of 8 meters from the ground. There is only one question, which is how far from the base of the building would it land? So that is going to be a horizontal displacement. So by inspection, this is clearly a projectile motion type of problem, correct? With horizontal projection, okay? So if you look at your vector, isn't it a vector which is clearly along the x-axis right here? So it is all x component, and it has no y component. That makes sense, okay? It's all along the x-axis. All right, so to look for displacement, isn't it true that for a projectile motion thrown horizontally, the x component proceeds without any acceleration, correct? So it's going to be moving with a constant speed all throughout. And therefore, if I want to find out where it will be, I need to multiply that velocity of how fast it is going with how long it will take to get there, all right? But we don't know this time. We don't know how long it will get to the ground. And therefore, although this is my working equation, and so you will get credit if you put this in as your working equation, we need to solve for time first. That makes sense, all right? How do we solve for the time? Did we say that, and I did a demo for this, if you recall, guys, where I threw an object sideways and dropped one at the same time. Do you remember that it took the same amount of time? So we said that the motion of this object projected horizontally, that y motion, is similar to just dropping an object, okay? And we already know how to solve for how long it will take an object to hit the ground if you just drop it. That makes sense, okay? So if I look at my given value, 8 meters is a displacement along the y-axis. And it is negative because it is below the reference point. So what I need to find out right now is, okay, if I drop an object here, it will get to the ground 8 meters below at the same time that I throw this object sideways at 2 meters per second. So why don't I just take advantage of that information, right? Analyze free fall. Well, for free fall, there is an expression to relate displacement vertically with the time of fall, which is this. Delta y is bit plus 1/2 at squared. You make some translations. Delta x to delta y, vi to viy, the y component, and acceleration to gravitational acceleration. Okay? So your initial velocity along y is 0, similar to an object that is dropped, so this whole term here disappears. So you're down to just delta y is 1/2 gt squared. You can substitute everything. Note how important you putting the negative sign there is, otherwise you will end up with negative time. Not possible, all right? 1.3 seconds, which you will eventually plug here to get your displacement. Questions here, all right? Make sure that your final answer has the correct unit. Stop that, because I want to say something here.